Due to the increasingly complex electromagnetic environment, filtering antennas with anti-interference capabilities have received extensive attention. There are 3 design methods for filter antennas, such as directly cascading the antenna with the filter, or replacing the last-order resonator of the filter with the antenna. However, both 2 methods have some disadvantages. To solve these problems, we propose a new filtering structure. This antenna adopts 2 orthogonal slots as radiators and carves 4 V-shaped slots below the feeding line. The proposed V-shaped slot has 2 functions. Firstly, each slot can generate a radiation zero point outside the band. Secondly, it can also increase the gain of the antenna at the edge of the working frequency band. By gradually increasing the number of slot lines, the antenna eventually generates 4 radiation zeros in the upper stop band. Firstly, the metal short-circuit columns are used to excite the antenna, enabling it to work in full-wave mode. The real and imaginary parts of the input impedance are stable at around 2.1 GHz, which is easy to achieve a wideband impedance matching by this excitation method. The input impedance at 1.1 GHz is very high, which leads to the first radiation null. The currents along the slot oscillate in the half-wavelength mode. The V-shaped slot and the feeding line above it form a bandstop structure. While generating the second null, it also generates a radiation point, resonant mode 1, which improves the edge gain. Based on that, adding up the number of V-shaped slots can yield null 3 to null 5. Through physical processing and measurement, we verified the antenna. The gain suppression of its upper and lower stop bands is 25.7 dB and 19.8 dB respectively, and the suppression width of the upper stop band reaches 4.01 times the center frequency. In addition, the radiation patterns obtained from measurement are also basically consistent with the simulation results. Based on the first work, we designed a new type of bandpass filter to further suppress out-of-band interference signals. Based on the stepped impedance resonator structure, 3 resonant points can be achieved within the band. Furthermore, by using differential coupling and quarter wavelength open line, 4 transmission nulls can be generated, achieving a wide stop band width. The filter is installed on the back of the reflector and cascaded with the antenna. The gain suppression of its upper and lower stop bands is 43.5 dB and 24.8 dB respectively, and the suppression width of the high-frequency stop band reaches 4.79 times the center frequency. By using V-shaped slots and the bandpass filter, these 2 filtering antennas we designed have achieved good results. It can be seen that the designed filter antenna not only has a simple structure, but also achieves excellent filtering capabilities. Thanks for your attention, and we welcome any questions you may have.